Alright guys, we're back to finish up target 1C, which we're doing operations with both rational and irrational numbers, and then deciding if the answer is still rational or irrational. So, yesterday we looked at what rational and irrational numbers are, and then we added. So if you look at our table, today we still have multiplication and division. And if you look, multiplication and division are very similar. When I have two rational numbers, it's always rational for both multiplication and division. If I have one rational and one irrational, just like before, it's always irrational or always irrational and always irrational, right? So that one irrational will always give you an irrational number. Then, if I have two irrational numbers, then for these ones, it can be rational or it can be irrational. So for that one, I have to check, right? So the only time it really is the one you have to make a decision on is when you have two irrational numbers for multiplication and division, right? So let's look at some examples. Go ahead and turn the page, right? So when I'm multiplying with radicals, right? Here, I multiply the coefficients, and I multiply the bases, what's underneath that radical. So if you look at example 13, I don't have any coefficients. I only have what's under the radical. The square root of 10 times the square root of 10, right? So I write both of those under the same radical, 10 times 10. I'm multiplying what's inside. So 10 times 10 is 100. Now, checking that out on my calculator, right, I would always do the square root of 100, right, is 10. So that's just a number. So that's my answer. And remember, this is just an integer, so this is rational. Looking at example 14, I have 2 square root 3 and 4 square root 12. So I'm multiplying those. So I first want to multiply my coefficients with outside, right? So I have 2 times 4. Then I want to multiply them with the bases. This is different from addition because I don't care if my bases are the same or not. Only in addition do they have to be the same. Here, we can add them. We can multiply them. Right? So I have 2 times 4 and 3 times 12. So 2 times 4 is 8, and 3 times 12 is 36. Okay? Then I still want to take the square root of that. Right? But I still have this 8 here. This 8 hasn't changed. I'm going to multiply by whatever the square root of 36 is. The square root of 36, right, if we type it in our calculator, is 6. So we have 8 times 6. And 8 times 6 is 48. So again, here's another time when I have two irrational numbers, and when I multiply them, it becomes rational, because that's just an integer. Looking at example 15, I have the square root of 15 times the square root of 6. Okay? So I'm going to have the square root of, right? Well, 15 and 6 are both on the inside. Side of 15 times 6. And the square root of 15 and 15 times 6, right? When I write that out, you should get 90. Okay? So what is the square root of 90 a number, an integer, or do I get some weird decimal, right? And here I get some weird decimal. So then I can make the decision that this is irrational, right? Because I don't get a nice integer, I just leave it as a radical. Then, looking at example 16, right, now here I have a square root and a rational exponent. So the first thing I'm going to do is change that rational exponent. This is really the square root of 3 times the square root of 3, right? Going back to what we did in 1b, right? Switching between rational exponents and radicals. Now I can multiply these two, right? Those 3's are what I'm multiplying together underneath the radical. So that's 3 times 3. And 3 times 3 is 9. And then if I use my calculator, the square root of 9 is 3. And so that's rational, because just like the other ones, it's an integer. Okay? So sometimes you'll get rational, and sometimes you'll get irrational. Alright. Looking at our next set of problems, now we're going to divide. This is just like what we did with multiplying. You'll divide the coefficients, if there are any, and then divide the bases, what's under the square root sign, what's under your radical. So here, what's under my radical is the square root of 27, right? So 27 and 3. I don't know why this isn't allowing me to do anything. There it goes. Right, so then under my radical, I just divide those, right, under one radical. So 27 divided by 3 is 9. And then I type that in my calculator. The square root of 9, again, is just 3. So since it's just 3, that's rational. Let's look at example 18. So again, I'm dividing these two, 85 and 5. So I just have to write that under one radical, 85 divided by 5. When I divide those, 85 divided by 5 is 17. So I get the square root of 17. If I type that into my calculator, right, the square root of 17 is 4.1231111, right? So that's not a perfect square. So that's my final answer. And then if this is rational or irrational, since it has that radical in it, it's irrational. Alright, that's all we're doing today. So go ahead and try these problems on your own, and we'll go over them tomorrow. Have a good evening.